So hey folks, name's Graham Shepard. I'm one of the principal product managers here at Palo Alto that's leading the SD-WAN branch security as well as our overall SASE connectivity and journey here. So what Mike and I wanted to do today was talk around the constructs of Prisma SD-WAN and from a SASE branch, what ZTNA constructs we have that can be leveraged for you guys to be able to enforce policy and provide segmentation. So we're going to walk through some core key principles that make up our ZTNA policy and how they can be leveraged and what additional capabilities we've developed over the last coming couple of months that can help really provide better adaptive access control. In addition to that, we're going to be talking about some net new innovations that we just released this past quarter, talking about how we're also integrating into switch and Wi-Fi, and how we can bring in that intelligence to help not only operation visibility, but also drive more intelligent segmentation. So, you know, to start off, right, when we talk about policies, right, there's three important constructs that we leverage within Palo Alto across our entire security fabric, right? And that is app ID, user ID, and device ID, right? When we write policies, obviously the goal here is to write, least privileged access policies based on context awareness of those users, the devices, and the applications that they're accessing. So these three core principles as part of our SASE solution allows you to provide both networking and security functions within the branch, as well as delivered from cloud security and back within your data center. So you can have contextual awareness at all points in time on what that traffic flow is, who's requesting that data, right? What applications they're leveraging. So you can write granular policies within that branch to provide east-west segmentation, as well as north-south access. So all of these have been part of Prisma SD-WAN for quite some time, but we're going to talk about, once again, just how these are configured and deployed, as well as some additional things that we've developed that provides adaptive access control, right? These aren't static in nature, all three of these, right? These are being continually run and verified as traffic goes through the ION, as users change posture, as devices are talking to different things. So how can you write adaptive access control that leverages all this intelligence that we're continually seeing from the devices, the apps, the people to provide better segmentation? So first and foremost, App ID, right? As part of our 6.4 release, right, we have completely unified the App ID across the board with Palo Alto. So whether it's a next-gen firewall or whether it's Prisma Access, right? As part of now Prisma SD-WAN, we have over 4,000 native applications once you move to 6.4.1. When you look in the application page, you'll actually see the device and version capability, and what version needs to be run to be able to detect that application. And this list will continue to grow as we get updates from the Pen App ID, right? And obviously, if there's any requirements in code, it'll show you in terms of the device compatibility matrix. So you'll continue to get more apps as part of this unified App ID as based on that App ID content release. In addition to that, right, user ID is something that we released back in the 6.2 timeframe. Just to give a little quick recap of what we did with user ID is we leveraged the user ID concept from Palo Alto and integrated this with the Cloud Identity Engine. So as part of our Strata Cloud Manager, Cloud Identity Engine plays a critical role in terms of connecting to the IDPs to basically be able to provision user and group mapping information, right? So CIE is where you log into to create the connection to Azure, to Okta, any of the IDPs in terms of learning that information. In addition to that, right, we use a user ID agent as part of our DC ions to learn about user to IP mapping information, right? Today, that's done to connecting to a next-gen firewall. We have plans in improving that to get that also directly from CIE, but that user ID agent, right, we can learn user IP mappings through things like internal host detection with our GP agent. We can learn with event logs with Microsoft AD, and there's a variety of different other ways that we can get that user IP mapping information fed from the agent to our Prisma SD-WAN controller, which then basically takes all this information, meaning the users and the groups, plus the binding, and sends it down to the branches. right? This allows you to have granular policies that not only reference an application, but also can reference a user and a group. Now, in terms of configuration for this and licenses, right, there's no special license other than having a Prisma SD-WAN subscription, right, which you are required to have to run Prisma SD-WAN ions, right, gets you access to configure CIE. Right? And so when you configure a CIE, there's two prerequisites that have to be done. First, we need to configure the cloud identity engine in terms of the principal name. What do we expect in terms of our user and group mapping? And then obviously the last piece is configuring the user ID agent, right? This would be on the DCI on connecting to that physical firewall to learn the user IP mappings. Last step would be to actually configure the security policies. Now, before we get there, another piece that has something that we've released that's relatively new is the concept of adaptive user risk from an IDP. So inside CIE, when you connect to Azure or Okta or any IDP, right, from there, you're learning the user and group information for your organization. But we have another thing called a dynamic user group, otherwise known as CDUG, that CIE can create. Right. So in this case, you see something called a high risk CDUG. And basically, this is a group that's created within CIE that's distributed to Prisma SD-WAN as well as to other parts of the Palo Alto ecosystem like NGFW. And what we can do here is leveraging risk levels that we learn from the IDP. Based on a user's risk score, we can add them to this group. And what it allows us to do is provide adaptive access for users that an IDP tell us might be high risk. So Mike here's on with me. Mike typically logs in, right? If Mike's healthy, right, I'm going to learn his username and I'm going to learn all his group information. But let's just say for whatever reason, Microsoft Azure classifies Mike as a high risk user. What can happen here is it'll automatically add him to this high risk user group, which then in turn will be displayed in Prisma SD-WAN from a policy, not only from a security, but a networking as well. So what this allows me to do is I can say, hey, any user that has been associated with the high risk group that I've learned through my IDP through its risk score, I can contain that user. Maybe I want to contain their access east-west to not allow them to talk to anything within my branch. I can also, even from a path policy, force all their traffic to, let's say, Prisma Access for more granular inspection. So using adaptive access, it allows me to continually monitor all my users. If for whatever reason they are flagged by the IDP due to high risk, that could be because they're logging in from a foreign country or wherever it is, right? There could be different reasons why you might want to add them to these groups. Then you can contain them, you can segment them, and you can also force their traffic wherever you would like to be able to get more granularly inspected. So CDUGs allow us to create this adaptive access, continuously monitoring user connectivity, user access, and providing those risk scores to provide that segmentation or path selection policy.
That's great. Thanks, Graham. And now let's move over into device ID because it's, rounding out the picture. As Graham mentioned, the three main constructs in the policy. We have users, we have apps, but what about things, right? Devices in which, you don't have a user login, no agent able to install. How do we secure and first, how do we discover all those devices? And with the IoT security visibility capability built into SD-WAN, right, we now have the ability, just like NGFWs, we've had this actually for a couple of releases now and are continuing to enhance it with enforcement with the latest 6.5 to release. So here, what we're describing, sorry, Graham, go back, is just the discovery process that the ION goes through to discover all these IoT devices, right? We use things like DHCP snooping and ARP, but we also have the ability to do SNMP crawling and using the ION as an anchor, if you will, to crawl the network. Now, crawling the LAN or even crawling over the WAN to other third-party locations to kind of discover these devices as we see fit. Now, once we identify all the devices here, we go to the next page. We talk about the configuration steps, right? One, this is a SASE solution, right? So in order to have IoT security license add-on, this has to be a SASE deployment, meaning Prisma SD-WAN plus Prisma Access, Strata Cloud managed, of course. And then to enable this discovery, one, we have the simple checkbox on at the site level, but and then we also have the option to do a discovery profile using the SNMP crawling I just described in the previous page. Next page. And here is just an example of what the IoT discovery profiles look like and where you would configure it within Strata Cloud Manager. Again, simply you're just specifying some basic SNMP information, right? Username, password if SNMP v3, and of course the starting point that you want to just do the crawling from. But once we've crawled the network, okay, so once you define that profile, the next thing you would do is attach it at the site level. And on the next page, we have the IoT visibility checkbox, and most of the customers literally just hit that checkbox and do enable, and we don't have to do the SNMP crawling profile. That is an optional configuration based off of your network environment. But again, once all of the telemetry is collected, it's going to get shipped up to the IoT security service for analysis and discovery. And that's where we have the IoT security dashboard right here. And this is, again, part of Strata Cloud Manager, right, under your insights page. Right. And so the IoT security dashboard provides information about devices on the network, their device profiles, their operating systems, and kind of how they're distributed across different subnets. Now, additionally, they display the total number of active alerts and vulnerabilities available. So if we look at the next page here, we can see the list of alerts and the vulnerability distribution across all the discovered devices. And this is all based off of behavior, right? So it's not only just looking at static information like I said, ARP and DHCP for the initial discovery of it, but then we do the profiling, right? So we're looking at things like the traffic logs and how and which destinations these devices are speaking to. And then based off of that, we can then craft policy based off of the risk of the device. So if we look here, you can see in the dashboard, the SD-WAN site, we can see all of the devices that have been discovered at the different SD-WAN sites within our environment. And they're, the vendor, the operating system, IP address information, and then the profile, right? And that profile is what's going to be leveraged within your policy. So if we look at the next page here, again, as Graham was showing earlier, you had the ability to specify user information to say block east-west segment, do east-west segmentations for high-risk users. Well, we can do the same concept here, again, and block devices. So in this example, I'm saying block my high-risk device, an Amazon device, just for the sake of this example, from speaking with any sort of Apple or PC Windows devices within the environment, right? So to prevent that IoT device from speaking with something on the corporate network, if you will, and only constraining it to what it needs to speak to, really driving that least privilege access architecture.
Yeah, so just to summarize before we get into the Wi-Fi switching integration, which is sort of a net new innovation, right? To what Mike and I referenced, right? These core constructs for least privilege access, app, user, and device, right? They're not just static in nature, right? We're continuing monitoring what applications are being accessed. We're continuing monitoring user activity and learning from our IDPs, risk scores. And with device ID, we're continuing monitoring all that traffic and what devices are talking to in their risk level. And all of these pieces can be leveraged to provide, adaptive access control within the ION, which offers, a layer 7 stateful based zone firewall, right? So you can provide segmentation, and then you can leverage these constructs also to steer traffic, on how you want to communicate, like I said, up to Prisma access to have that more fine-grained inspection. Now, addition to what we've been doing within ZTNA there, right, we're also looking at enhancements from our SASE portfolio on how to bring in more telemetry and more insights into the LAN and Wi-Fi, right? The switching and the Wi-Fi below, as well as the client's connectivity into that. And we're looking at doing that for a variety of different reasons, right? One, looking at simplified management, right, and onboarding of these, devices. A second is around, operational visibility, right? Being able to, tie users to ports, to APs, to their connectivity of health, and how we can stitch all that together to provide a better operational experience. And you'll see how we can do that within our SASE flow browser. And then last, the security, right? Anything that obviously goes through the ION, we can provide restrictions to based on app, user, device, provide that segmentation. But we're also looking at how we can extend that down to the switch and the AP to provide even more fine-grained segmentation or blocking of clients that may be malicious within the network. So the way we're looking at this is currently exploring and connecting with different ODM providers, right? Who are managing, maintaining, and manufacturing these switches and access points. And we'll go ahead and look to expand those over the course of the next coming years with additional options there. And the first tech partner that we just released is a company called Shasta. And what we've done with Shasta at the initial release is worked on sort of those key principles that I referenced in terms of initial operation, onboarding, right, visibility, as well as segmentation and security. And so what we'll kind of walk through here is this full experience that is now available as part of the Shasta integration, right? We have the ability to be able to bring up their switches and access points with zero-touch provisioning to quickly get associated with the site, get associated with the network configuration, associated with SSIDs, so you can go ahead and get clients up and running and a full branch operational in under 10 minutes from a pure zero-touch provisioning. In addition to that, like we're looking at in terms of the telemetry we can bring in from the clients as they connect to the switches and access points, provide information of how they're connected, which SSID they're connected to, their health, right? And we'll continue to look at driving more of that visibility throughout the portal. And then last but least, not is the security, right? How do we continue to enhance and get better integration from identity as well as segmentation and being able to block those clients all the way down to the access port themselves. And so we'll look at expanding this with other tech partners as well, but Shasta is the first one we released and out there publicly now. So I'm going to walk through just sort of a slide demonstration of how that looks and works. First and foremost, Shasta is going to be delivered initially here as a Cloud Blade option, right? So you can go ahead and provision the Cloud Blade. It'll automatically create and get connected to the Shasta portal. That provides us then a seamless way to provision access points and switches as part of our zero-touch provisioning process. So in a site configuration, the only additional thing you'll need to do is go ahead and configure basically an onboarding subnet. So as these Shasta access points and switches get connected behind the ION, they pull a DHCP IP address, they will automatically get provisioned as part of this HQ Lab site. So as you can see there, we'll have another widget within our home configuration page of a site. And in there, basically, it'll have a wizard that'll walk you through the zero-touch provisioning workflow, right? In this case, right, you can see we'll have multiple switches and access points below. There's no limit to how many we can have below that site. As those devices come online, they're going to use this onboarding subnet, right? This onboarding subnet is where they'll pull their management IP addresses. And as part of this, they'll leverage that to go ahead and get connected to the Shasta Cloud, which will automatically deploy the switch configuration. In addition to that, it'll automatically deploy the set of Wi-Fi networks that you create here, right? These could be guest networks, they could be employee networks. You can see the different types of authentications that are available there, right? These will automatically be provisioned as part of this onboarding process, whether it's 1, 2, or 10 access points that live behind that branch site. Last thing is obviously just provisioning the ION on the LAN side, right? Once we assign this subnet and we assign the ION as the default gateway, it'll start handing out those addresses. And part of that onboarding process is embedding basically a DHCP information in this class ID and the value you can see there from an option that these APs and switches will know how to register to Shasta and how to go ahead and automatically get assigned to this HQ Lab site for their full configuration. So once this onboarding subnet's done, nothing else needs to be happened. You can go ahead and start then connecting access points and switches behind this site, and they will automatically get permissioned with all the configuration that they need for clients to start plugging in and accessing whatever resources they want, not only within the site, but also out to Prisma Access or back to the data center or the internet. Now, post-configuration, we'll talk about some of the initial monitoring things that we've brought to bear. And obviously, these will continue to get enhanced over the next coming months. But clicking on Monitor will actually take you to the Shasta Cloud Blade. So in the Shasta Cloud Blade, we'll have a variety of different tabs for monitoring. First one you'll land on is the general, which we're just going to tell you holistically throughout your entire tenant, how many switches are being managed, how many access points are being managed, all through the Cloud Blade, as well as what is the total number of connected clients to those switches and access points throughout the entire tenant. Switches, right? We'll provide you the names of the switches, how they're attached to which site, their status of connectivity, what IP address they're using for management, as well as the profiles, right? These profiles are basically configuration. This is the access point, sorry. The configuration of which, networks, what SSIDs, right? What configurations they have. All of these will be hyperlinks so you can easily launch into Shasta and see the detailed configurations of them themselves as well. Clients, right? We'll have the full list of clients here. This will reference, which site they're connected to, if they've been associated name from in Shasta, which network, which infrastructure, if they're wireless or wired, right? How long they've been connected, what SSID channel. So you'll have a full list of all the clients connected. And obviously over time, we're going to look at taking this information out of the Cloud Blade and just directly embedding it within the site configuration UI, as well as other places within our portal from a networking operation and troubleshooting perspective. Last but not least here, the ability to also block, right? So Shasta will provide us the ability to do segmentation. So we can easily stop east-west movement within a VLAN or within an SSID. But in addition to that, we can also block clients outright. Right. So if you're seeing anything malicious in nature, not only can you control it from adaptive access control within Prisma SD-WAN, but you can even go to the point of blocking them completely from being onboarded on the network, whether they're connected into a switch or into an AP. You can outright block that client based on their MAC address. So you have a full list of the block list here, as well as the date created. You can add and remove them as you see fit. Now, from a visibility perspective, SASE Flow Browser is something we released about 2-3 months ago that really provided a complete end-to-end visibility view of a client connecting in from the LAN to the ION, all the way to the application they're accessing, even if that was through Prisma Access, right? So the SASE Flow Browser really gives you that one page to look holistically and have the visibility of that end-to-end flow. Our plan as part of this WAN and Li-Fi integration is to obviously drive more visibility to the left there, right? In terms of, user ID, device ID, switch connectivity, AP connectivity, all that information will be displayed on the left in terms of how that user is connected, what's their health, right? What's the network they're attached to, and then obviously all the security enforcement done within the branch ION, and even to the sense of if they go through Prisma Access, what policy was applied, were they blocked because of a URL filtering or threat prevention. So from an end-to-end flow perspective, not only from a security, but as well as a health and connectivity, all of those things we're going to continue to enrich here within our SASE Flow browser to get a better monitoring and operational outcome. Mike, anything you want to add in that I might have left out in terms of the Shasta integration?
No, I think we covered, as you're showing here, the LAN and the user information, right? That'll be expanded upon. So the information we had in the Cloud Blade will start to kind of make its way into this SASE Flow browser, right? For that, just-in-time access to that useful troubleshooting data, such as, like I said, the switch port information, packet drops on the switches, and any Wi-Fi signal degradations that we're detecting, right? So that true end-to-end service delivery chain to help with your troubleshooting workflows.
Awesome. So just to summarize kind of what we went through, from a least privileged access, right? App, user, and device are critical components in terms of writing those segmentation policies, as well as how you want to do path selection. There's additional capabilities from adaptive access control that you guys can leverage within CIE, which is our dynamic user groups, and leveraging threat scores, right, from your IDPs, as well as device ID, right? We'll continue to look at improving that, and you can leverage, obviously, those risk scores and that information there in terms of identifying devices to write clear and concise security policies. And then beyond that, right, we'll continue to look and develop beyond this first initial tech partnership with Shasta on how we can bring in, operational simplicity from a LAN and Wi-Fi connectivity, from both monitoring as well as a security, right? This is starting out initially as that Cloud Blade. We'll be looking at additional tech partners to bring on board, as well as we'll be expanding that to take that telemetry data and populate it in more places, such as, what we have there in the SASE Flow browser. Additionally, what you'll see within our NOC dashboard, as well as in our site configuration page, to give you that information from a user connectivity front and center as you may be troubleshooting a network connectivity problem or an experience issue that a user might be complaining about.